So in this lesson, we've been talking about solving trig equations, which a lot of was review from last year when we did degrees. The only new thing we've done so far is solve using radians, okay? That you should be getting more and more comfortable with now. This type of equation that we're going to finish with, okay? Second degree. Another way you can call them is quadratic trig equations. Remember last year, we solved many quadratic equations. Those are the ones that have an x squared in them. Okay? We solved trig equations last year and reviewed this year. Now we're going to combine them. So they look a little confusing to start, but you'll get used to seeing what they look like. Okay? So we are asked to solve this trig equation, 2 times cos squared theta minus 1 equals 0. And this says to me, answer in degrees. Okay? Here's what I suggest you do with quadratic trig equations. Take the trig, which in this case is cos theta, replace it with x. Because if you do that, it might make it look a little easier for you to solve. How would you solve this one? Add 1 to both sides. Divide 2. And then plus minus square root of 1 over 2. Now, this is kind of a special one, because remember, we're looking to see when we solve these things, is it a unit circle value? Can we use the unit circle, or do we have to use a calculator? Okay. Well, I can take this further. This means the square root of 1 over the square root of 2. Well, square root of 1 is 1. So I could write it like that, plus minus 1 over root 2. However, last year, remember, we took out the radicals in the denominator, the square roots. What did I multiply by? Root 2 over root 2. So that gives me plus minus root 2 over 2. That's a lot of work there. But there's a reason for that, because is that a unit circle value? Yes. Okay, and remember, there are 2 solutions here. My answer could be plus root 2 over 2, or my answer could be negative root 2 over 2. And sorry, instead of doing x, I'm going to mess up some space here. Remember, we at the beginning replaced cos theta with x. Replace it back once you've solved. So cos theta equals root 2 over 2, or cos theta equals negative root 2 over 2. Are those unit circle values? Yeah. So both of them are, and we have to solve both equations. So what values in degrees, remember, we're working in? What angles correspond to root 2 over 2 for the x coordinate? 45 and 850. So that answers this equation. this equation, what angles cos is the x coordinate negative root 2 over 2? 135. 250. 225, pardon me. Okay. So you notice when we have quadratic trig equations, there's more solutions. Because usually we end up having to solve two separate equations after we do the factoring. Okay? Let's look at this one. Radians this time. I've got three terms. So instead of tan theta, I'm just going to write x for the time being. And then I'm going to replace tan theta back a little later on. Oops. Let's replace that. So this is a trinomial. What are the first two terms? 2x and x. I know I have to have 1 and 1. And because it's negative, one of them has to be plus, one of them has to be minus. Question is, which one's going to give me this in the middle? Minus 1 plus 1. That gives me 2x minus 1x, which is plus 1x.
The other way around.
What do you mean the other way around?
And plus and then.
Okay, so switch the signs, right? That's right. That works, because that gives me minus 2x plus 1x, which together make minus 1x. And we should remember how to solve these. We take each of the factors and make them equal to 0. So 2x plus 1 equals 0. X minus 1 equals 0. So here x will equal negative 1 over 2. And here x will equal 1. Now, replace tan theta back. And now I'm going to solve each one of these. Now this is a unit circle value, but not for tan, is it? Because remember, tan is y divide x. So there's no pair on the unit circle, pair of coordinates where the y divide x is negative a half. Okay, so I'm going to have to do this the long way. What quadrants is tan negative?
2
and 4. Now I got to find the reference angle by taking the tan inverse of, be careful, 1/2. You always have to change it to positive when you take the reference angle, always. Otherwise, you'll get a completely different angle that won't work. So if we do that, we're going to get 0.464. Remember radians on your calculator for this one? So in quadrant 2 and quadrant 4, how would I find theta in quadrant 2 if this is my reference angle? I minus 0.464. And in quadrant 4, it's 2 pi minus 0.464. That's going to give me my two answers. And they work out to 2.678. So that's one solution. And 5.819. That's another solution. Remember, I've only solved half the equation right now. I got to, or half the entire equation. I got to solve this thing now. Is there a unit circle coordinate where the y divided the x is 1?
Yeah.
Yes. Remember, anything divide itself is 1, right? So which unit circle coordinates are the x's and y's identical? Sorry?
49.
Radians. Pi over 4, because that's 45 degrees, and 3 pi over 4, because the 2 points are root 2 over 2 comma root 2 over 2 in quadrant 1, and negative root 2 over 2 comma negative root 2 over 2 in quadrant 3. So this is actually a unit circle one. We can do it. We can finish it right away. And you guys said pi over 4 and 3 pi over 4. So you see we've got 4 solutions to this one. So they look complex, but they're just combining two things that you guys have done for a couple of years. So when you see the square with trig, change the trig to x, figure out what type of factor. Oops. So I'm going to go 2x squared minus x equals 0. How would you factor that? It's not a trinomial. GCF, what can I take out? I can take an x out, and the other factor will be? Yeah. Set each of these to 0. This one's already solved for x, so we'll replace the cos back. Cos theta. Add 1, divide 2, x is going to be 1/2. So cos theta is going to be 1/2. And now we're ready to solve each one. And fortunately, these are both unit circle values. So what angles in in degrees is the x coordinate 0? $90? Is that what you said? Did you say 90? You're right. There's one more. 270. That's right, too. So there's 2 answers. And what angles is the x coordinate positive 1/2 in degrees? 30? You sure?
Wait, no. 600?
300 is, and what's the other one? 60, right? Like in the first quadrant, 1/2 is the short one, so it must go up to 60 degrees. And then down in quadrant 4, 300 degrees. And by the way, on your test, you will get a blank unit circle to work from. Okay? You obviously have to know the filled in one, but you will get a blank one. And that's the same with the provincial exam too. They'll give you one of those too. Okay. I see the squares, or I see the square. I'm going to replace it with x. And then replace it back once I solve it. So I can actually do the trig portion. What do I got to do with this one? Yeah, I got to move everything so it's on one side. Can't factor it until everything's on one side and zero's on the other. This is your basic trinomial, your x squared one. I heard 6 and 1, I heard 3 and 2. What about positive and negatives? Okay. -3 plus 2, that's right. Make each one equal to 0. And you know, you can just replace tan theta back here if you want. You can replace tan theta back anytime you want. The only reason we replaced it to begin with is made our factoring a little bit easier to look at. So I get tan theta equals 3. And tan theta equals -2. Which unfortunately are neither unit circle. Yep. So you're going to be punching away. Remember, quadrants, reference angle, then get your 2 answers. Quadrants for this one, tan positive. 1, 3. Tan negative. 2, 4. Reference angle. And if you like, here's a little hint that avoids a communication error. Because a lot of times students will forget to put the little r, which is technically a communication error because you're not finding theta yet. You're finding the reference angle. So if you can't remember that, just do this. Just do tan inverse 3 and then give your answer. Don't even put that in if you can't remember it. Because then you'll avoid a communication error. Your steps are still right. Okay? Because like I said, if you put that, just theta, that's a communication error. Because it's the reference angle you're finding. How would I find the reference angle here? Tan inverse 2. Remember, you always have to make it positive. So now we got some work to do. So this is going to give us, remember I'm in radians, I believe. Yes, I'm in radians. 1.249 for that one. 1.107 for this one. So there's the 2 pieces from each equation that I need. So in quadrant 1 and in quadrant 3 here, well, theta in quadrant 1, that's pretty straightforward. It's the same as the reference angle. And in quadrant 3,
it's pi plus the reference angle, which gives us about 4.391.
Notice I'm going 3 decimal places every time. That's the assumption. Okay.
For this equation, my answers are in quadrants 2 and 4. So in quadrant 2, theta is going to be pi minus the reference angle of this one, 1.107.
Which gives me about 2.035.
And in quadrant 4, it's going to be 2 pi minus the reference angle.
Which gives me about
5.176. So again,
notice with these kind of questions, there usually seems to be about 4 solutions. Not all the time, but most of the time. Sometimes there may only be 3.
okay, let's look at a couple more. Replace the sine theta with x squared.
And I want you guys to go from there. At least get it down to factored and your 2 equations. Get it that far.
Okay, so I have to move the 2 over. So I can factor. And I should get x minus 2 times x plus 1. And now I'm going to replace x back with sine theta. So sine theta minus 2 is equal to 0 for this one, or sine theta equals 2. Replace x with sine theta, so sine theta plus 1 equals 0, or theta equals negative 1. I recognize that as a unit circle value.
And there's actually only one answer to this one. 3 pi over 2. This one, as soon as you get to finding your reference angle, you're going to get an error.
So yes, you can say, oh, sine's positive in quadrants 1 and 2. I'm going to find my reference angle by doing sine inverse 2, but when I do that on my calculator, I get an error, which means there's no solution. There's no solution to this one.
So actually, in the whole equation, only one angle works. Okay? And then this one here, notice we've got one of the reciprocal trig functions.
Well, I'll deal with that later. Looks very similar to the previous one in terms of factoring. The numbers will be different. So I should get that.
X minus 3, x plus 2.
Replace it back with cosecant theta minus 3 equals 0. This one becomes cosecant theta plus 2 equals 0. So cosecant theta equals 3 on this one. Cosecant theta equals -2 on this one. And now
What? Did I make, uh-oh, I see the hands. What did I do?
We can't.
Oh. Thank you.
versus. And sequence. Thank you.
Now what? Do you remember how to deal with this one?
Yeah. Flip each side. I'm going to flip this to its reciprocal cos, which means I got to flip 3. 1/3.
Because 3 is the same as 3/1. Flip it to get 1/3.
This becomes cos.
-1/2.
I recognize that.
But not this one. So I got to do half calculator, half unit circle.
Well, let's deal with the unit circle one first.
Wait, no.
5/3. So cos is -1/2. That's this one and this one. That's 2π/3. 4π/3.
And I got my 2 answers there.
This one I got to do quadrants reference angle. Oops. Quadrants 1 and 4. And again, even if you want to just do this, get your answer like this. It's supposed to be a squiggle one on a great attempt.
The cos inverse of 1/3, and remembering we're in radians, which
Will give us 1.231. So in quadrant 1, the actual angle is the same as the reference angle. It's easy. But in quadrant 4, 2π minus the reference angle will give me my answer in quadrant 4, which is 5.052.
okay. All of those trig equations we did, all your answers were between 0 and 360 degrees or 0 and 2π. You may be asked to give the general solution. The general solution is, what are all the angles that fit the equation? Okay?
So like I said, what we've been doing up to this point, all our answers have been in the first revolution.
0 to 2 pi or 0 to 360 degrees. Okay? But remember, we can find equivalent angles by adding a revolution, adding 2 revolutions, adding 3 revolutions, subtracting a revolution, subtracting. What kind of angles do we call those? Please tell me you remember. I thought I heard it. Coterminal. Yes, coterminal. So you can add a series of 2 pi's if you're in radians and subtract a series of 2 pi's, or you could add a series of 360s or subtract a series of 360 degrees. Okay. So if we're told to give all, then we have to write notation for all the coterminal angles. Okay. So we could subtract infinitely many and add infinitely many. So how do you recognize a trig equation that's asking you for all the solutions? It'll say something like all real solutions. Or it'll give you everything notation. Remember, everything in interval notation is negative infinity to positive infinity. So if you see these things, okay, that means we have to include every revolution. So like if one of our solutions was pi over 2, well, we'd have to add 2 pi to get another one. And then we'd have to add 4 pi to get another one. And then we'd have to add 6 pi, and then 8 pi, then 10 pi. Not only add, but subtract as well. So how do we deal with this? You guys have seen this notation before. We do plus 2 pi k . We do plus 2 pi k, where k is an integer, k-e-z. We've seen that notation before. Whenever you see that or use that notation, it means you're stating all angles. So plus 2 pi k, k-e-z. That's the only thing you have to add. You solve everything exactly the same way. You just add this stuff at the end. Okay? So like here, notice this one says, solve this equation, and it's a nice simple equation. It's not a quadratic equation, because there's no square. But it says, notice, gives us this. That should tell you, oh, right, I got to add this at the end of my answer. As soon as you see that, whatever answer you get, this gets added to it. So let's solve this one. Cos x equals, notice we're not using theta this time, we're using x. Are we dealing with a unit circle value? Yep. So what angles is the x coordinate? Negative root 2 over 2. Two pi over 3? No, because we're using the unit circle. We're getting directly to the answers. Where negative 2 pi, it's here and here.
3 pi over 4, and 5 pi over 4. Now take these answers and write them like this. We're done. So you solve it like you would if you were in a restricted domain, but then you just add this to represent all possible angles coterminal to these two. You know what? I'm not going to worry about example 7. We can do example 8. It's pretty much got the same kind of stuff in it. Notice this one, and sometimes this may happen. It's been factored for you. You don't have to worry about doing any factoring. So the only thing you have to do is set each one equal to 0. And solve each one. Well, what would cos theta equal here? 1 over 3.
That's not a unit circle, so I got to go the long way.
This one would work out to sine theta equals negative root 3 over 2, which is a unit circle value, so I can find the answers directly. Y values negative root 3 over 2. Remember, negative root 3 over 2 is the long one, so it should be down here and down here. Which one is this? 5 pi over 3. That's actually this one. This one's 5 pi over 3, which means this one would be yeah, this is 5 pi over 3, and this is less. Let's go less than 5 pi. 3 pi over 3 is the same as pi, which it's not. Okay? This one, I'm going to do the quadrants. Quadrants. Hello. 1 and 4. Both sides positive. Reference angle, do cos inverse 1/3. I'll give you this one. It's approximately 1.231, which means my two answers. Well, the first answer in quadrant 1 is going to be the same as the reference angle, 1.231. Quadrant 4, I'm going to do a little bit of math to find the actual angle by doing 2 pi minus the reference angle, which gives me about 5.052. But notice, I'm asked for all the answers. So what do? We write the answers we got. 1.231, 5.052, and what do we add to them? What do we add to them? At plus 2 pi k, AEZ.
Whatever you do, don't blend it. Don't go, oh, 2Ks, I'm just gonna go like this. Okay, because that's just crazy. Look at that, even my smart board wanted to cross it out before I got to it.